Hello, everyone. Today's lesson is about electric charge. We're going to learn how do electric charges behave. We're going to start by types of electric charges. We have protons, which is located inside the nucleus or in the center of the atom, and it's positive. Electrons revolve around or move freely around the nucleus, and they're negatively charged. Now that we have conductors, one of the terms that we have to learn, conductors are allows the flow of electrons, which is makes it easy flow of electricity. Okay, they're freely moving, so they conduct electricity, and it's usually metals like aluminum, gold, copper, silver, because they're always positively charged, and it has a sea. It's called, you learned this in chemistry a couple of years. It's a sea of electrons freely moving, conducting electricity. All positive because metals are positive. They lose electrons and become positive. The second term is insulators. They resist the flow or inhibit the flow of electrons. So they hold tightly to the valence electrons. Valence just means the outer electrons. So we have one orbit, outer orbit. So valence is just the electrons moving on the outer shell. These inhibitors or insulators are plastics, glass, or rubber, like any of these. Okay? Interaction between charges. Now, magnets have act the same way. One side is positive, one side is negative. So the like repel one another. If the positive and positive come to close, they're going to repel one another. Opposites, positive and negative, will attract one another. Statics. Statics in Latin means stay. The atom wants to stay neutral, where the number of protons equals the number of electrons. Now, an atom becomes charged when it gains or loses. If it gains, it becomes negative. If it loses electrons, it becomes positive. So protons stay the same in the nucleus. The one that gains or loses are electrons. Now, the charges builds up static electricity. And the static electricity, they want to build up and stay. Now, they don't stay that way for long. Very soon, they discharge. Okay? Through, if you touch something or through lightning, it discharges. So, transferring of static charge. So, through friction, if you're walking on a carpet, you're transferred from rubbing, for example, the carpet, walking on carpet, you build up static. And conduction is just direct transfer. So if you touch a doorknob or something, it just transfers to the doorknob. Or the Van de Graaff machine, that was this one right here. When you touch it, it just transfers to your body or to the doorknob or lightning. Now, induction, it just, when it comes closer together, it disturbs another object. So it kind of, if it's neutral, it affects the positive. It pushes away the, well, if it's neutral, it's going to affect it. So it's going to makes it charged. It affects the neutral atom, and it briefly it will make it charged a little bit. So the force field of a highly negative charge pushes electrons away and makes it positive, and then it attracts. So if a neutral atom comes with a close proximity of negatively charged ion, it pushes away it or repels the negative temporarily and makes it positive, and they attract. Okay, so in a highly negatively charged, uh, they when it comes close to a neutral atom, it briefly pushes away the negative, so it becomes positive, and then they attract. Okay. Um, Now, I said that before. It doesn't last forever. So once you touch a doorknob or another body, is discharged. So lightning, sparks, or humidity, where it's polar, it just releases that or pulls the electrons off. Negatively charged object. Okay, and prevent the static charges. All right, so it restores, the goal here is to restore equilibrium. Okay, and that's, then there are like, for every section in your textbook, there is 4 or 5 activities. Choose one, take a picture, videotape it, and just upload it. I'll give you a slide where you can upload whichever activity you chose. All right, that's it. Hope that helps. Good luck.